mic, so I have no idea how this recording is going to sound. And I also don't have my drawing pad, so it'll be like my finger. So we'll see how that goes. Cool. Any questions before we start? We'll do like 2 minutes for questions. Homework questions, project questions. Yeah.
I guess I'm a little bit confused on when we have an asterisk in parentheses and outside of parentheses also, and how that works.
Cool. Yeah, that's a good question. So let's go back to regular expression syntax, right? So the seventh rule we have here, right? We have R star, right? So the asterisk character. So this means whatever's in here, this, if you think of it as an operator, the star operator is going to apply to whatever regular expression is in there. So that's also an issue of precedence that we didn't really talk about. We talked about precedence of A bar B, which is very small that you can't read, right? We talked about A bar B dot C, right? So which one, what is this, where would the parentheses be on this example? B dot C, yeah, exactly. A or B dot C, right? So we're going to also define, the problem is we didn't say, what does this mean? Right? So we're going to say the star operator has the highest precedence, kind of like, if you think of it, exponentiation, right? So if I have x squared, which I can't really do here, let's see if I can draw it. We're going to see how this goes. X squared, wow, this is going to be a fun class. Kind of looks like a 2 if you move your head in the right way. Right, so we have x squared. So if I had something like y plus x to the third, right? It's clear from our years of math training that this, what's being cubed is not y plus x, what's being cubed is x. Similarly, if I had y plus x to the third here, now it's being cubed. Y plus x, thank you. Get us out of that awkward silence. Right, so we're going to do the exact same thing here with regular expressions. Right, so using that same logic and that same intuition, what would this mean? What's being starred, if you will? Just B, exactly. So this would be different than, so here what's the star operator applied to? The regular expression A bar B, exactly. Cool, does that answer your question?
Yeah.
Awesome. Any other regular expression stuff that we talked about? Any of the other operators? So I guess we can briefly mention, right? It was this way in the homework. So we're going to get rid of the dot operator in most of the things that we talk about. Right? So we can write this. This is the exact same thing as saying A bar B dot C. Right? So that's why on the second part of the homework it says we omit the dot operator. So we're not going to deal with the dot operator. And this just makes it easier to write regular expressions. So we can write the regular expression ABC. So this would be A dot B dot C. Cool. Yeah.
One more.
Yep.
We were a little bit confused, some of us, about the little ambiguity in the instructions. Do you have to show work? Or
On the homework, you got to think about it from our perspective, right? So you give us the wrong answer. How many points can you be expected to get? 0, right? You just wrote down something maybe arbitrarily. I don't know how you got that. But if you show us your work, not only can we help you give you better feedback because we can identify exactly where you went wrong, we can give you some partial credit because it's clear that you went through and tried to do everything. And maybe we say, oh, you made a mistake here, but everything else after that was still right, even though you got the wrong answer. So it's really more about you. Like, show your work. It's better for you. It's better for us. It's better for everyone involved.
but if you feel it's unnecessary for one part, it's
Like true false, you probably would not need to unless you really want to. Yeah. I mean, the homeworks aren't the homeworks are really midterm practice that you can get some points for. So that's the point of the homeworks. And these are all questions that I actually drew from previous midterms and putting them in homeworks. Any other questions? Cool. All right. So we covered this. So now we go back and actually define the star operator because we have already done this. Okay, so I looked this up on Wikipedia. I believe his name is pronounced Kleene. He was actually, so I'll probably refer to him much, much later towards the end of the semester when everybody's already forgotten what I'm saying right now. Because he was the student of the guy who invented lambda calculus. So we like kind of go full circle here. So Kleene Star, he was the guy who defined the star operator. So we already kind of built up an intuition on Friday about what does this star operator mean. So what was that intuition? How would we like describe what this operator does in English? Yeah, 0 or more repetitions of what? Of R. Yeah, exactly. Right? So intuitively, what this is when we say 0 or more, we're saying that LR star is equal to the empty set, the set containing the empty set. So what's the LR star here? What am I trying to define? A language. Yes, so we're defining a set of strings, right? So we're saying what is the language that is described by the regular expression R star? Right? So 0 or more times, what's going to be in that set? 0 repetitions. Epsilon. Yeah, so we're going to be epsilon, and we're going to union that with the language described by just R, so that would be 1 repetition. 2 repetitions would be LR concatenated with LR. Union that set with LR concatenated with LR concatenated with LR, and then union that with, and so on and so forth until to infinity. Right? So that's intuitively what we want to do here. So what we're going to do is define this as, we're going to define a new kind of function on languages, if you will, or a relation here. We're going to say L0 of R is the set containing epsilon. And so we're going to say for any given Li, this is the one that came before it, right? L of I minus 1 concatenated with Lr. So does everybody agree with this? That L2 would be Lr concatenated with Lr. And then concatenated with, well, the set containing epsilon, but what's that going to be? Yeah, empty string, right? When we concatenate with the empty string, we don't have to do that. And so we can define the LR star as the union for all I greater than or equal to 0 of LIR. Right? So should this change the way you think about the R star operator? Pretty much. Shakes your thoughts to its core. The intuition is still the same. The intuition of 0 or more repetitions is the same, right? But we can break it down mathematically and say exactly what we mean here. Notice that this doesn't say anything about what, so this is all possible 2-character strings that made up that match R, right? That's what this LR.LR is, right? So when we look at 3-character strings like LR, 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 right? This is going to be all 3 strings, all strings that match the regular expression concatenated together. And so it doesn't matter whatever matched in here, matched in here, matched in here. It's all possible combinations are valid. Okay, so some examples, right? We've seen this. Actually, this was our previous example, so this is a good way into preference, right? Or operator preference. So here we have the language described by the regular expression A bar B star, right? A or B star. And so intuitively, what strings should be in this resulting set? A followed by any number of B's? So is epsilon going to be in there? It's awesome. It's like waves of answers crashing. So somebody say yes, why?
You can take only B star, right?
Okay, someone want to raise their hand? Yeah, in the front.
Then take B star and
Right, so it's A or B star, right? So the or would be B star, and B is 0 or more times is epsilon, right? The 0 time is epsilon. Is A going to be in there?
Yes.
Yes, from the other or. What about AA?
No.
What about AB?
No.
No?
No, because they're not concatenating.
Exactly. They're not concatenating. So describe this in English. What is this in English? Yeah.
This is epsilon A or any number of repeating B's.
So this describes exactly epsilon, A, the string A, and a string containing any number of B's. Yeah.
Wait, is it a singular string?
Aren't you the one who answered?
Is
Huh? Say that again.
it a singular string containing any number of
All strings containing all B's.
So like B, 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 okay.
Everything, yes. Cool. So we have A, epsilon, B, 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 all number of B's. What about this? What's the difference here? What does this mean in English?
all strings contain A and B. And
All strings containing A and B. Yeah, so it's the, there's also multiple ways to describe these, right? But we have 0 or more what? A's and B's. Yeah, exactly. It's A. We have any number of, what's inside there? A or B. Right? So it's going to be, is epsilon going to be in this set?
Yes.
Yeah, epsilon's going to be in there. What about A?
Yes.
What about B?
Yes.
AA?
Yes.
AB? BA? That's awesome. Right? So how do we figure this out?
A or B into A or B star.
So a set of A based on
Yeah, so we want the language to... Yeah, so it's going to be the union for all I. I'm not going to draw the for all I thing. The union of L... Let's see, L... I wonder if I can do superscript. Bigger, smaller, that doesn't really help. Bold. All right, Li of what? What's inside here, though? Right? Because this is what's inside, this is what's being starred, right? The regular expression is R star, where R is A or B. Right? And so this is going to be the language, well, first it's going to be, we know, do I want to draw epsilon? It's going to be tricky. Union with L, A or B. Union with L, A or B concatenated with the language described by A or B. Union with so on and so forth. Right? So what's going to be this set? A and B. Yeah, the set containing A and the set containing B. What about in this set? A, A, B, B, A, B, B. Is that all of them? Yeah. Right? And this set will be all three-letter strings that are all composed of A or B. Right? So now let's go back to whatever the original question was. What was the original question? Does anyone remember? It was like BB or BA. So is BA in this? Yeah. Perfect. Questions on this? So it's once again, it doesn't mean any number of A's. Right? It's not specifying 0 or more A's. It's specifying 0 or more A or B's. That's why it can be AB, 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 AB. Every possible string that has composed solely of A's and B's is going to be in this set. Right? So this is exactly what we did, right? We kind of broke it down and developed an intuition of what was happening. And so now we know all the strings that are in here. So if I gave you a string and said, is it in the language described by A or B star, you could say whether it is or is not, right? Cool. Questions? Yeah.
So is A star to the power star is equal to A star?
Mm. So what does this mean?
A star.
Wow.
Any number of A's.
Yeah, so 0 or more A's. So if we think about just this, what strings are in here? A, epsilon, A, right? So all those strings concatenated with all number of A's, it's going to be the same set of strings, right? Because any more A's you add on there, that set is already going to be inside this set. Is there what? Sorry, say that again.
So does that mean like how long? Because you can distance like for example, the inside of A star and it has to be the second one has to be A two like you gotta have four, you can't have just two. So go like one. So just go like 1, 2, 4.
Sorry, say that again.
The star, the stars aren't like it's
Stars-
arbitrary number.
It's like a loop, right? It's like a super simple loop that only goes from 0 to infinity, right? And so if you put that loop in another loop that just goes 0 to infinity, and because it's all sets, they're already in there, right? Does that make sense? So like if you think about what's inside here, this is what's inside the language described by A star is going to be a set containing epsilon, my crappy epsilon, A, right? A string with a bunch of A's. Every string that possibly has A's. So now if I said, what is A star concatenated with A star? So is epsilon going to be in there? Yes, we're going to have epsilon. Is A going to be in there?
Yes.
From what, though? Yeah, because there's going to be an A in A star, and there'll be an epsilon in A star. When you concatenate those together, you will get A.
But so if you can't to get epsilon with A doesn't make it 0.
No, A concatenated with epsilon is A, right? Because you have a string, you're concatenating it with the empty string. So it's the original string again. Right? And so even if we're concatenating like this and this, that string is already inside this set because this set contains every string that has every possible length of A's. So yes. Right? So you can kind of informally show this. Yeah.
Now, is there a way to stop it from going to infinity with the amount of A's you put in it?
No. You can put a finite number of A's. So you can do A. So let's see, we want A. How long do you want me to go?
Oh, no, 1 second. Going through the loop of the language A star.
The star means 0 to infinitely many times. So
Is there a way to stop it from going in?
no. So this is why one way you could do that is to have a fixed number of, you could specify exactly, you want all strings of A's from 0 to 10, right? You could specify that in a regular expression, but you have to specify every possible string. Or you can maybe do it a little bit more succinctly, but you can't say, I want to do A star, but only from 0 to 10. Yeah.
Is A epsilon A equals to A?
Yes. Mm-hmm.
You know, like threes, are those supposed to be threes or epsilon?
No, they're epsilon. There's epsilons in there when they're supposed to be epsilons. It's just because I don't want to keep drawing. I should probably copy the epsilon from my slides, then I could use it here. But yeah, for right now, no. Those are all characters. You'll see an epsilon when there's an epsilon. Don't worry. Yeah.
So that means we can simplify languages.
You can simplify what?
With language, if it's like A star or B star or star, we can just write A or B.
Yeah, if we said A or B or C, and like these are all starred, and this whole thing is starred. Maybe. You tell me.
So we can just
It's part of understanding regular expressions. So can you make an incorrect simplification? No. Right? Like let's look at, you can't say, so well, that's fine. Is the language described by A star or B star? So what's this? What does this describe in English? Any amount of A's or any amount of B's. So is that the same thing as the language described by A or B star? No, why not? Name a string that's in one of the sets but not in the other set. AB, right? The string AB is in this, right? This is any number of A's or B's. This is all strings containing all A's and strings containing all B's, but not A and B combinations, right? So this is why you gotta be careful when thinking about simplifying it. So if you simplify it and then you mess it up, well then everything's bad. Cool. All right. Okay, so now we've developed a little bit of some intuition and some formalism around regular expressions. And you're going to continue to develop this in your homeworks. And I'm going to see if I can, yeah. Whoa, that's a weird, it's tilting. Okay, apparently I don't understand how this desk works. Is the whole thing moving up? Okay. It started tilting this way, so don't want to ruin this desk. Okay, cool. So we've been studying regular expressions. You're going to study them in your homework. And now we want to say, okay, we were using regular expressions to be able to define tokens. Right? This was the entire purpose of looking at and studying regular expressions, is in the context of lexical analysis, we want to create tokens from regular expressions. So what we're going to do is we're going to define the tokens using regular expressions. So let's do an exercise. So I want to define a regular expression called letter. What would be in that regular expression? What types of strings would I want to match?
String with one character.
Yeah, like a letter. Yeah, so I need to specify exactly which characters I want, right? So A or B or C or D or E or F, G, H. I hope I don't mess this up. Okay. Right, all the way there. So what strings do I not want to be in here? Epsilon, we wouldn't want an empty string to be considered a letter. Numbers, right? So this is part of when you're writing a regular expression, you want to think not only what should match, but what shouldn't match so you could properly validate that. So this is part of actually creating test cases like you're doing in Project 1. You need to think about doing test cases even for regular expressions. Right? What about uppercase letters? Would you like a language where you could only write in lowercase? No? Somebody say yes.
Yes.
And then back it up with a fact and an opinion.
Well, I mean, more stuff to work with, so like deal with, right?
More stuff to work with and deal with? So what are the pros and cons from like a language design perspective? Yeah.
Caps are aggressive.
Was or what? Say it again.
Caps are much more.
Oh, caps are aggressive. Ooh, I like that actually. So you don't code like this, like. You don't do this when you code? Maybe in comments. Why? Okay. Right? Yeah. So it's a little rude using all caps. What else? What was that? Special characters, okay, we'll get to that in a second. But focusing just on the uppercase and lowercase, it seems really pedantic to focus on such a tiny thing, right? But have you ever used a language where there's functions called, and there's a parse, or and you have autocorrect doing weird things, right? So is it kind of weird that you can have a language, so are these the same functions? Are they different functions? I mean, it depends on your language, right? This is part of that design decision. So you could maybe think like only allowing lowercase characters, that could be a nice way to get rid of this problem, right? All functions are all lowercase. So if you look at the C standard library, I think every function name is, I want to say 8 characters or less, and also the file names, because that was the limits of the Unix system that they were developing in at the time. So we still have that baggage now when you're dealing with C functions, and they're all lowercase. So even you guys, the Mac file system does not actually do uppercase and lowercase. There's no difference. All files are considered one case. So you can open a file with 2 different things and it'll be the same file. It's crazy. I can't believe the Dropbox people had to like deal with that when they're doing file syncing. But anyway, so this is something to think about, right? So we're defining a language. These tiny things that we think about now about defining tokens for letters, that's going to affect everything, like how the programs look and how things feel as we're going on. Okay, so we have letters. Those are cool. We like letters. What about, do we ever want to use digits, like numbers in our programming language? Yeah? What kind? Do you guys want to use Roman numerals?
Yes.
Oh, that'd be a I shouldn't have said that. That'd be a great midterm question. Okay. So what would a digit be? All right, we'll go there. Right, all the way to 9? Is that good? So then, how can we define a number?
We also need sign, decimal place.
So what's the problem with just digit star? Epsilon, right? We would match the empty string. Is the empty string a number? No? What base of number are we talking about? Says who? Is this a number? It could be. Yeah, in hex it is. Right? So what kind of, okay, so first let's define what kind of number system do we want to define? Base 10, thank you. Okay, good. Right? So we can't do just digit star. One or more of? No, we can't use that operator. Yeah, I like the concatenation this way. Digit dot digit star. Right? So this is all strings consisting of all digits. So do I want this to be a number in my programming language? Why?
I mean, is that the same thing as 0 according to our language?
You tell me. We're defining the language now.
If it's not, I don't want to use your language.
If it's not, you don't want to use this poor man's language?
I mean, you can't have, I guess, like 0 and 0, 0 both, do they mean 0?
Yes.
They should be. I guess you can't basically have different values that match the same thing.
So in C, are these the same things? Yes? What do you want to bet on it? Oh, wait, actually maybe I did this wrong. Okay, what about now? Did that change things? So what are the kinds of different notations and base numbers that you've learned about in your career? Binary? How do you do binary in C? Can you do that? Like as a literal? I think if you put either the B in front of it or the B afterwards, I can't remember, but there is a way to write binary. Do you know? 0B. Oh, 0B at the start? Got it. That makes sense. So this would be a binary number, which can be really useful, right? You're dealing with crazy systems. You may need the raw binary. The raw binary signature. What else? What are some other base systems? Octal? Why? So what's octal? Base 8? How do you do octal in C? Zero X? Leading 0. So what's 0x for? Hex. Right? And so octal is a leading 0. So then, are these the same number? So should we have regular expressions and tokens that match them as if they were the same? No, probably not, right? That doesn't make sense. We'd want to maybe have different tokens. So let's go back to our number. So now we need to, we already said we're doing base 10 numbers, right? So do we want leading zeros? No. So how do we do it? Remove 0, like minus 0? Yeah, so why don't we can define, just like this, we developed a shorthand, right? We can call it, I don't know, p digit. Or we can not. There we go. Right? Every digit besides 0. So then now what would our number be? P digit star? Somebody want to take a crack at it? Because there's a lot of you. Yeah. Let's see. P digit dot digit star. So then what does this match? So let's think about what things match, what things don't match. Does it match this? Why not? Right, 0 is not a p digit. So this defines all strings that start with a p digit and have any number of 0 through 9 after it. What was that? Or 0, why or 0? What test case does that fail? Only 0. Should this be a number?
Yes.
Yeah. Is this inside the language described by this regular expression? No, because we said that it has to start with a p digit. Right? So how can I fix this? Somebody who just said it. Or 0. Yeah.
Can we add epsilon into pre-digit so we can concatenate it to 0?
So what would happen if we did that? So let's add. All right. Since there was confusion, I will. I think it got worse. Oh, it's in italics too. That's not fun. Okay. And can you just go back to the way everything is? Oh, fun. Smaller.
The bigger and smaller.
It's not super specific program. Whatever. Sure, this is exactly what I wanted to do. Okay. Okay, so we just changed this and it took 5 minutes, but we added epsilon to p digit. So now does this token capture what we want to capture as a number? Why not? So is all these zeros in this language? Yes, because this would be epsilon and then it'd be any number of zeros. Exactly. Cool. So should we keep this in here? No, we should not. Okay. So now are we good? We don't have negatives. Okay, we'll deal with just natural numbers right now. It's going to complicate things. Okay. Okay, cool. So we did all those. We did numbers. Oh, cool. Okay, now let's go back. So we did letters, right? Now we want to say, what is an ID? So ID is short here for identifier. So what are things that are identifiers in our programming languages? Variable names? What else?
Statement.
What was that?
Statements. Like this.
Statements. Statements use identifiers, yeah, to perform operations on them. Variable names. What else? Function names. Yeah, these are all like identifiers. You want to give a name to these things. Constructors, functions, although usually constructors are like a keyword, but yeah. Right? Maybe any kind of like, what was that? Oh, structure, yeah, like a struct. Yeah, you want to name a struct, naming classes, class names, constants, enums, right? All kinds of stuff. And you need to know, what is an identifier? What does an ID look like? And so what are some of the rules for identifiers in programming languages that you're used to? So raise your hand, just give us like, I don't know, the general rules maybe that you remember in what language. Yeah.
Can't start with a number.
Can't start with a number. Why? Because then how would it know if it's a digit or a number, right? It may not be able to tell. So that could be one reason why. I don't know whether that's specifically why. But yeah, in a lot of languages, you can't start a variable name with a number. Yeah.
You can't use a keyword like new or Alec or...
Yeah, so you can't use a keyword or if or while. Think about if you could define that to be a function. Yeah. Say that again? No spaces. Why is that important? Yeah, exactly. How do you know when one ID ends and another one begins, right? That would be madness. Underscore? Yeah, you may want an underscore. So underscore kind of actually gets around that fact, right? You can't have spaces, but you may actually want to separate words visually, so you can use an underscore for that. Or you can do camel casing, right? That's another way of doing that. What else? Any other weird rules? Yeah.
Does it start with special characters like $sign?
Yeah, so usually you can't start with a special character either. So usually you have to start with what? A letter, right? As we've defined it.
Can you start with an underscore?
Can you start with what?
You can start with an underscore.
You could maybe also start with an underscore. Yeah. Sure, let's add this in here. I like that. So then what can follow an identifier? So what is it, like letters? Like letters or what? Digits. Underscores. What special characters though? Can I do this? Well, this. This? So actually one of the things that maybe you've never thought about, but I've actually found, so some languages actually allow you to use a question mark inside of a variable name, which it seems silly, but if you have a variable called maybe is admin, right? It's actually kind of nice to read because it reads just like a question, right? It's a Boolean. Is it an admin? If it's true, the person's an admin. If it's false, it's false. It's actually super handy. Some languages do this, and it makes the code a little bit, just that little bit more legible and readable. Now, would you want to do like is admin and is, I don't know, on phone? Probably not. This would be super annoying, right? Okay, so letter, digit, underscore. Any other special characters? What a hyphen? Depends on the language. Some languages use hyphens, some don't. A lot of them don't. It actually seems kind of limiting, right? We can think about maybe Unicode characters and all that. So is this it? Am I done? I want to star where? Like this? Cool. So does this get across what we want? Sweet. Right? Okay. So this is basically everything that we did. This is just slightly different than what we've seen before. We just didn't add the underscore, but otherwise it's exactly the same. And this is reiterating the fact that we left out the dot operator here, but we still know exactly what this means. So you're free to use this syntax on homeworks, midterms, leaving out the dot operator. It makes things a little bit more clear if you include it, but you don't have to. And so we have cool things, like we can say, yes, this is an ID, this is not an ID. Okay. So now we've got our number down, right? So let's verify. So we already saw this was wrong, we saw this was wrong, we added p digits. So you guys already did all this stuff. I don't need to teach it. Teach yourselves. Okay, we needed the 0. So, now, how do we define a decimal number? So let's think about first, let's go, what are some valid decimals? So we want what, 10.10? Is that valid?
Yes.
What are some other examples?
0.5.
0.5? 0.5? All right, we're getting off track. Anybody want to add an example that's not one of these? 0.05. Okay, interesting. And I just did not put that in the right place. All right, we're going to stop.
3 times 10 to the negative 6.
Not going to deal with scientific notation. That would be a completely different issue. Yes. Cool. So how do we write, what is a decimal?
A number followed by a dot.
Is this correct? Why not? What does this regular expression mean based on everything we know so far? A number followed by a number. Is it 2 digits though?
Yes. That's right.
What's the one element that's in num concatenated with num that is not in num? 0, 0. Right? So this is not the same thing as num. Because we have 0 concatenated with 0, and we already said we specifically don't want the number 0, 0 in our numbers. Okay. So we've hit a point where we want to use an operator. We want to use the period. We want to use the period character, but not as a regular expression character. So just like when you're writing a string in C or Python, or C, Java, whatever, and using double quotes, if you want to actually include double quotes in that string, what do? A backslash. Yeah, you need an escape character to tell Java or C that, hey, here I'm not talking about that special character double quote which stops the string. I'm talking about a literal double quote character. So we're going to use the same thing here. We're going to use the backslash to just say backslash period matches the period character, right? Concatenated with, so here we'd have concatenation on both sides, right? So does this get us what we want?
Oh, can we just put it in the parentheses in the middle?
Yeah, you can always put things in parentheses. You have unlimited parentheses. Do what you want. But you can't go like this. That's not a valid regular expression. Okay, so let's self-test, right? So we first came up with some cases. But what did we do with these cases? What types of test cases are these? Positive. What does that mean, positive? That they're super happy? No, these are all strings that we know should be in the language described by decimal, right? We actually didn't come up with any test cases that shouldn't be in decimal, right? But let's deal with that in a second. So let's walk through. Is 10.10 in num? Or in decimal? So is it in num? No. Is it in decimal? Yes, we have a number followed by a period followed by a number. Great. What about this? What about this? No, why not? So what do we want to do with our language? Do we want to accept this or do we want to change this? Let's change this. Always change the requirements. It's way easier than changing what you already did. Right? So we'll say all decimals in our language have to start with a 0, right? They can't be any 0.5. We always want it to be a 0 there. It's actually more clear that way, right? It's not clear whether you meant to type in 1.5 and forgot the 1. You actually are explicitly telling us you want 0.5. Yeah?
So if you did want to get it, you just work with
Yes. Yes, you could do that. Okay, what about this? 0.5? Yes, already in. 3.4? This is in here? What about this? Why not? Is 0.5 a number? So then what are we going to do?
Or num or 0.
Did I just change it like that? Yeah? If I change it like this, is that a decimal? Do I want it to be a decimal? No, by the same logic as it requiring the leading, right? I should have them explicitly type in something here. Do I also want this?
It depends if you want precision.
Ooh, that would be a good thing. Yeah, if you're doing a scientific programming language where the significance of digits matters, maybe you do want this. But let's say we don't. Because to the computer only has 32, 64 bits, right? So these are exactly going to be represented the same way. Or possibly. It depends. So how can we fix this? Epsilon?
Key digit or 0. You can't use the star because the star is like what's causing this epsilon to screw us up.
Exactly. Also, we don't just want p-digit star, right? Because we want to have leading zeros, right? Because what about, but we do want this, right? So we want a number or what? It's kind of easier if we say, okay, the number does a lot of what we want, right? We didn't say anything that we have to write the smallest possible regular expression, right? So number or what?
digits or zero.
Would that do? We could say num. Or we could even say, if we want to be a little bit more specific, we also may want 0 or 0 star. All right, think about it.